Alright, so for this first lesson, guys, let's talk about parts of an atom. Now, a long time ago, we extensively talked about parts of an atom during CP Physical Science. So whenever you took CP Physical Science, you should have learned everything there is to know about parts of an atom. So if we start this, let's first talk about the three main parts of an atom. There are three subatomic particles. The first one are the protons. Now remember, protons have a positive charge. I kept them blue, that way when you look at the diagram over here, you can easily see them as blue. So again, easy way to remember protons, protons positive, positive protons, P and P. But what's also super important to know is that protons tell you what element you're going to be. When you change the protons, you're going to change the element. However many protons are is what element you are. So for example, carbon has 6 protons. There is nothing else in the universe, nothing that has 6 protons but carbon. They will never, ever find a new element with 7 protons. It's impossible. We already have an element with 7 protons. It's nitrogen. If you were to take away some of those protons, like let's say you took 2 protons away from nitrogen, it's not nitrogen anymore. If you take 2 away from 7, now you have 5 protons. Element 5 is boron. Now how am I figuring that out? Well, if I kind of go a little fast through this, on your periodic table, which you can see later in Moodle, there's a whole number. The whole number is called the atomic number. It's the most important number there is. The atomic number tells you how many protons you have. So protons, again, protons tell you what element you have. The atomic number always equals protons, and protons always equal the atomic number. So for example, hydrogen, it has the atomic number 1. There we go, 1. Which means if your atomic number is 1, you have 1 proton. And that's it. Gotta get in the space. There you go. 1 proton. That's it. Just another quick thing to show you that. Watch this little diagram. If I change the protons, there you go. No protons, and there's no such thing as an element. So I have 1 proton. Notice, when I change the protons, I'm literally changing the element. Now, you can see the electrons are changing too. We'll talk about that later. The neutrons don't change the element whatsoever. We'll talk about why later on. But just notice, the important thing is this. Protons determine what element you are. You change the protons, you change the element. Alright, 3 minutes on protons. Pretty important stuff. So, protons have a positive charge. They determine the element. The next one, you have these green little spheres out here. These are the electrons. Now, are they really green in real life? Are protons really blue? No. They just did to color code this thing. But anyways, these little negative charges are called electrons. Electrons have a negative charge. There's no easy way to memorize that. You know, P, positive, protons, P, that's easy to remember. Electrons are just negative. You just got to memorize that. But you'll notice that the electrons are circling out here. And we'll talk about what that is, what they're circling, and why later on. The red spheres, which you notice have no charge, are called neutrons. And an easy way to remember neutrons are neutral, neutrons. Easy to remember. There's no charge. Now, besides knowing the 3 main types, which, come on, you better know, come on, get there, there it is, 3 main types. I'm learning how to use this thing for the first time. 3 main types, protons, electrons, and neutrons. It's vital you know where they are located. So, let's talk about that. The nucleus is an extremely small but hardcore dense, like that's where all the mass is. Hardcore dense part of the atom. And inside the nucleus, which you can see right here, that's where you find all your protons and neutrons. So all the protons and neutrons are inside the nucleus. Don't worry about mass number, we'll talk about that later. Outside the nucleus, spinning technically far away, are the electrons. Electrons spin around the nucleus, super far away from it. We're going to talk about later on about how atoms are mostly empty space, but that's not until after school starts. but just so you guys make sure you know this. The center of the atom is called the nucleus, and that's where you find protons and neutrons. Protons and neutrons. The electrons are found in what's called orbitals or electron clouds or energy levels. There's so many different names depending on which theory we're going by. So, hey, pop quiz. What are the three parts? That's right. Protons, neutrons, and electrons. Good job. We did it. We did it. Okay. The last part of these notes deal with what's known as a neutral atom. Neutral atoms is when the number of electrons equal the number of protons. So, if you have a periodic table available, if not, you don't, just go by my word on this one. We're gonna first figure out how many protons there are for iron, oxygen, and calcium. Well, if I look up iron on the periodic table, I'll notice it has the atomic number 26. And we already said earlier, what's the atomic number mean? Atomic number is how many protons there are. So, since the atomic number of iron is 26, there are 26 protons. Oxygen has the atomic number 8, which means there are 8 protons. Calcium, atomic number 20, 20 protons. Now, if I was to ask you, hey, how many electrons does it have? Well, you have to be specific. Is it a neutral atom or is it something else called an ion, which we'll talk about later on? For right now, it's neutral. And for it to be neutral, it has to have the same number of positive protons as negative electrons. So, if it's neutral, if I have 26 protons, I gotta have 26 electrons. If oxygen has 8 protons and it's neutral, it's gotta have 8 electrons. If calcium has 20 protons, it's gotta have 20 electrons. And again, I like to think of this as kind of like math terms. Think like this. Let's see if my numbers were right here. Oh, there you go. Cool. So, protons are positive, right? Protons are positive. So you have 20 protons, you have a positive 20. Now, let's say you have 20 electrons. Electrons are negative, right? So if you have 20 of those, you have negative 20. Well, what's positive 20 and negative 20 put together? Yeah, that's right. 0. Good job. You did it. You did it. You did it. Okay, it's 20. It's 0. I said 20. Slap my hand. It's 0. It's neutral. The protons and the electrons, the charges balance each other out. So they turn into 0. That's what it means to be neutral. Later on, we'll talk about what happens if it's not 0. But for now, neutral atoms, protons and electrons have to be the same value. Okay? So, let's review. 3 main parts of the atom. Protons, electrons, neutrons. Protons positive, electrons negative, neutrons neutral. Which one determines what element you are? What? Couldn't hear you. Hey, that's right. Good job. It's protons. Protons determine what element you are. Good job. What particle or particles are inside the nucleus? That's right. It is protons and neutrons. Protons and neutrons are inside the nucleus. The electrons are somewhere far, far, far out there, somewhere else in the electron cloud. And then finally, what has to be true in order to have a neutral atom? Come on, say it. Say it. All right, there you go. Good job. It's actually on the screen still. Sure. Dang it, my bad. It's when the protons and the electrons have to have the same amount. You have to have the same amount of electrons and protons. So there you go. 9 minutes in our very first screencast. What up? And I will see you in the next lesson.